and then we'll go into the microbiology of fermentation, followed by the word processing of Arabica coffees, some results from our experiences, and then some experiences we've had on dry processing. And I think at the end, after the stock, we're going to have a cupping of some coffees that we brought for your tasting or cupping. And okay. So, who's Lallemand? Lallemand is a company that was formed over a century ago, I think last century, let's call it that. And it's been in the hands of the Chagnon family, who are Canadian since 1952. It started production of yeast in 1923. So this is a company that produces yeast really worldwide, and we are in different industries, bakeries, wine, beer. We had beer tastings yesterday, so we do have yeast for that. Alcohol producers and animal and human nutrition, so probiotics, we are in there, pharmaceutical industries, and we are also in food and other agricultural industries like plant care, and we do have fuel ethanol as well. So all this we are playing with bugs, which is microorganisms, yeast and bacteria mostly, and sometimes we do deactivate those yeast and have products for nutrition and what have you. So we love playing with bugs, let's put it that way. There we go, those are the different industries that we play in. So, you know, we are specialists in producing yeast, and we produce lactic acid bacteria as well. We are fermentation specialists, let's call it that. And beyond that, we do a lot of research and development. So we put a lot of work into, you know, by the time we produce or launch a product, a lot of work has gone behind the scenes for us to get to that point. So even though they are microbes, they're actually quite difficult to handle, and one has to know that you're actually producing the right microorganism. Otherwise, chances of contamination is huge, because right around where we are, we've got lots of microorganisms that are floating in the air. So you can imagine when you're trying to produce one that you're telling people is the one that is producing, or that you're going to use in your fermentation, it's got to be the one that we say it is. Otherwise, we can have some unexpected consequences. So these are just the yeast plants that we have all over the world. I think there are close to 30 plants. And we do have a few bacterial plants. And okay, these are yeast and bacterial plants as well. And then lab research centers. And that's just a combination of all our commercial distribution. So we do have offices in many parts of the world. For coffee, we are starting. We've started coffee research about 6 years ago, and 2 years ago we launched our first product, and really this year is the year that we've done a full-on launch on, you know, the 3 strains that we sell in the coffee space. And so trials, we do a product, so you know, you can't just make people pay for the sake of paying. Anyway, we do work with research centers as well within the coffee space. So depending on the expertise we're looking at, if it's wine, we're going to work with people that are experts in wine. So research institutions that do research on wine, we will collaborate with them. For coffee, we'll also look for coffee research centers, then we'll collaborate with them. And we do have our internal research team, but they would work extensively with, because we can't have PhDs all the time in an organization, so we've got to work with those centers and sponsor those research projects. Okay, so now let's talk about yeast as a microorganism, as a living organism. it does look like, my pointer is this one, yes. Under the microscope, that's what yeast looks like. And we can have yeast, it produces sexually or asexually depending on the conditions that exist. So if it's good conditions, you know, it will be sexual. If it's not, it's going to be asexual. So they're going to start budding, and you know, so there we go. And where can you find yeast naturally? We find yeast everywhere, you know, and yeasts are different. So yeasts are different. One strain is different from the next, like a human being is different from a mouse. So that's how different the genetic makeup is. So, or the work they do. So depending on the yeast strain that you're looking at, it will do totally different things, and that's critical and important to know. And so just a bit of information about yeast, you know, in the early years, we had fermentation was used in bread making, but at that point, it was assigned to God's hands. And then in the 1680s, we had, you know, the first observation of yeast cells under a microscope by Antoine Lallemand, if you excuse my my pronunciation. And 1866, we had Louis Pasteur, you know, discovering the function of yeast. And 1996, we completely sequenced the genome of yeast. So a lot of work has gone into understanding yeast, because at the end of the day, when we understand what happens, it's actually quite close to the human genome. So they start by sequencing yeast, and then they apply that to human genetics, so which helps in medicine and every other things as well. So there we go. So within coffee, we find our yeast everywhere, in the soil, on the cherries, and also just in the atmosphere, we do have a lot of yeast floating around. So from a yeast point of view, the yeast that is mostly used, or that we work with, that is also easier to work with, is the Saccharomyces species. And what does Saccharomyces mean? Saccharomyces cerevisiae, Saccaro means sugar, myces is a fungus, and cerevisiae is a Roman goddess of agriculture. For those that didn't know, vis means vigor in Latin. So that's where the name comes from. So I just talk about Saccharomyces cerevisiae every day, and this is really, when you break it down, where they came up with the name. And you also have some non-Saccharomyces yeasts or species that also have, you know, their different activities and influences on your product. Might not be good, you know, bread in wines, for example, not a good thing. So depending on the species that you have, these can all exist in your coffee because they are naturally existent. So at the end of the day, you want to hopefully know what is making your coffee. And I think every year we do have some really, really interesting coffees that one makes, because there is a fermentation that is going on, whether we inoculate or we don't. From our side, we're coming with a product to inoculate. However, there is already an array of yeast species that are existing in your natural space where you are producing in your origin. So you can have some good flora, you know, existing, and they will be the ones to take control. And if they take control, you have that really, really great cup of coffee. These are just the diverse, uses for coffee that, for yeast that we are working on. So when you have Saccharomyces, this is a graph to show you the fermentation process in an indigenous setup. This is a graph done in wine. So you will see that Cerevisiae works very well in terms of its growth over time in a media that has got sugar, producing alcohol. So it's got certain attributes that are positive: strong fermentation capacity, resistance to alcohol, well-researched species. It's a well-researched species as well. And when it comes to non-Saccharomyces, it's a weak fermenter. However, you do get sensitivity to alcohol, which is not the case in coffee because, you know, we're not going to make alcohol when we're making coffee. So that could be interesting for coffee as well, because you can get some interesting flavors out of those non-Saccharomyces species as well. So just to now contextualize my talk within coffee space with research that is existing, why do we concentrate on Saccharomyces cerevisiae? It is a strain that is also easier to produce within a factory. So to produce and then to dry and then to transport it. So you want to make sure that the activity is maintained from the moment you start building up that, you know, that batch and growing it, and to the time that you dry it, it still needs to have good activity, because we need to have at least 10 to the 7 cells, which is 10 billion cells of yeast in an inoculation and in a gram of yeast. So if you don't have that, you're not going to have enough population to take over. Otherwise, something else can take over that fermentation. So here, just showing you that Saccharomyces cerevisiae is a dominant player within, you know, in a coffee. So they selected all these strains. They found them in a coffee. This was in Cerrado in Brazil, and after 48 hours, so this is at the beginning, so this is what they found. And then after 48 hours of fermentation, you have a dominance of Saccharomyces cerevisiae playing that role or still within your fermentation. The others have either disappeared or they are in smaller quantities. This one is grown a little bit. So these two clearly in this fermentation are probably influencing that fermentation more than anything else. This is also just a graph to show you that we do